All right, so I'm going to attempt to go through some of these questions. So on number 1, cosecant x times tangent x to secant x. So if I rewrite cosecant x times tangent x, in the next step I'll go ahead and rewrite cosecant x as 1 over sine x, and tangent x as sine x over cosine x. And so now I can see that sine for sine cancels, and I do end up with 1 over cosine, which is where I was trying to go. Or I guess I should really write that that's secant x. All right, so number 3, cosine squared times cosecant times secant to cotangent. So, I mean, if you're wondering why I know what to do in these problems, I'm kind of thinking about the fact that cotangent, when I read cotangent, I read it as cosine over sine. So if I make all of these guys as cosines and sines, hopefully it'll just end up. So since cosine squared is already cosine over sine, I'll just write that again, but I'll put it over 1. Cosecant, so I'm writing cosecant as 1 over sine, and secant as 1 over cosine. Alright, so what ends up happening is I have this square and I have this cosine. They end up crossing off. And when you go across the top now, all you have is a cosine on top and a sine on bottom, which is cotangent. Alright, number 5. I'm going to rewrite the problem, secant x minus cosine x. So, if you think about what this is, it's sine times tangent. So, not really sure what to do here, but when I get stuck, I look at this and I say, I don't really like secant. So I'll change him to 1 over cosine. And I'll change this to cosine over 1. Now, because this is minus, you can't just cross things off. You have to add the fractions. And in order to add the fractions, we need common denominators. So I'll get this with a common denominator. And I end up with 1 over cosine minus cosine squared over cosine, which is 1 minus cosine squared over cosine. Alright, so at this point I can say, well, 1 minus cosine squared, this is a Pythagorean theorem you should be familiar with, sine squared over cosine x. So let's break this up, because I think I'm kind of there. I've got a sine, I've got a sine. Tangent is sine with cosine, so let's just break that up. So I've got a sine, and I've got, that's a 1, a sine, and I've got a cosine left. So again, all I've done is I've broken sine squared into sine times sine and left the cosine on bottom. But this is tangent, and this is sine. So I'm done. Number 7 is a difference of squares. I don't really need to do this problem. So you get secant squared minus 1, which is tangent squared. Oops. Number 9 is an algebra problem. I call it algebra because you have to do cosine minus secant times itself. So if we FOIL this, cosine times cosine is cosine squared. Cosine times minus secant is minus 1. Minus 1 again. plus secant squared. And I'm going to break this up into this group and, oops, this group. Now, be really careful when you do this, because what I don't want you to do is forget that these two things are being added. So I'm going to put a little plus sign here. All I'm really doing is saying plus -1 instead of saying -1. All right, now if you look at your formula chart, there is something that looks pretty close to cosine squared minus 1, and that is 1 minus cosine squared. But that's not the same thing. You need to figure out how to make sense of this, but this makes negative sine squared. This is tangent squared, which is on your formula chart. Number 11, 1 plus cotangent squared over secant squared. If I rewrite that problem, I believe that 1 plus cotangent squared is on your formula chart as cosecant squared. And this is actually on your formula chart as well. Well, cosecant over secant is. Cosecant over secant is cotangent, therefore the squared is cotangent squared. All right, number 13 is probably the more difficult question of this group. Now, we're going to talk more about this kind of question tomorrow, but the idea behind this question is that this group is different than this group. And since they are both in this is in a denominator, it's like a group that it can't be separated. So what we have to do is we're going to have to multiply this group by what we see here to get common denominators, and same thing over here. So I end up with secant x plus tangent x multiplying top and bottom, and over here secant x minus tangent x, top and bottom. I'm trying to get a common denominator. Now this looks like it's about to be really ugly, but if we keep in mind that this is actually difference of squares, I've multiplied the conjugate, then it's really not that bad, because now on bottom I just have secant squared minus tangent squared. And on top I have secant x plus tangent x. And over here, same idea. Now, the beauty about this problem is that if you look on your formula chart, this actually changes to 1 in the denominator, and 1 in the denominator, which actually makes it, I mean, over 1 doesn't really matter. So then when I go to add, I have secant plus secant makes 2 secant. Tangent minus tangent goes away.